Hello everyone, welcome to the IM2 Test C version. I will take you through each one of these questions, starting with number 4. Number 4, we have to evaluate the expression using the given values, which means we need to plug in and then use our order of operations, PEMDAS. Okay, so I've plugged everything in, and now it's a matter of just using the order of operations. I'm going to start with my parentheses. On the inside of my parentheses, I need to start with 3 plus 5. That's like a parenthesis on the inside of parentheses. And then I have the minus 6 plus 4, another parenthesis within the larger set. So from here, I'm going to continue to work in the parentheses here. And first thing I'll do is multiply within the parentheses. Multiplication comes before the addition or subtraction, I see. And then I see a negative in front of a negative here. Minus times minus is plus. And then we will continue to work inside the parentheses. I have a 4 plus 16 plus 2, which is 22. And now from here, I've got everything wiped out from the inside of the parentheses, and I have negative 3 divided by 3 times 22. Now, from here, we have to use multiplication and division from left to right. So I'm going to start off with the negative 3 divided by 3, which is minus 1, and that is still connected to the 22 with a multiplication. So we will multiply negative 1 times 22, and that gives us a negative 22. For our next question, we have to solve for the unknown. We have to figure out what n is equal to. So we have to pull all the n's to one side and pull all the constants to the other and solve for n. The first thing I'm going to do is I'm going to get rid of my parentheses by distributing in the negative 7. That's going to give me a minus 16 plus 5n equals plus 42 minus 56n plus 3. So from here, it looks like I have some like terms on the right-hand side of my equal sign. So I'm going to deal with those to start. I have a minus 16 plus 5n equals 42 plus 3. That gives me a 45. And from here, I am going to pull all my terms with n to one side and all my constants to the other. I'm going to add 56 to both sides, 56n to both sides. And I'm also going to add 16 to both sides. And what that does for me is it crosses off these guys here, crosses off these guys here, and I have a 5n plus 56n, which gives me 61n on the left, and then I have a 45 plus 16, which gives me a 61 on the right. So I've I simplified to get an equation with the term with n on the left, the constant on the right, and so all I need to do is just divide both sides by 61 in order to get n all by itself, and that's a 1. I'm not going to show you the check, but I could plug in the 1 to determine if I truly have found the right answer. Let's look at our next problem. It's a similar question where we have to solve for the unknown value. I'm going to start off by multiplying, aka distributing, getting rid of those parentheses. So I have a 10x plus 30, and then plus 9x plus 4. And that's equal to x minus 5 plus 3. So before I start pulling my x terms to one side, my constants to the other, I'm going to see what I can combine on the left and the right. See that I have a 10x and a 9x. I can combine those on the left. I see that I have 30 and a 4. I can combine those. I also have a minus 5 and a 3 that I can combine. So let's go ahead and do that. I have 10x plus 9x, which is a 19x. I have a 30 plus 4, which is a 34. And then I have an x minus 2 now on the right. And so from here, we're going to go ahead and pull our x terms to one side, our constant terms to the other. I'm going to subtract x to both sides, and that will cross off the x's there. And 19 minus x is an 18x. And I'm also, in the same step, I'm going to subtract 34 to both sides. I'll pull my constants to the other side. So 34 minus 34, that crosses off. And then we have a minus 2 minus 34, which is a minus 36. So at this point here, I have to divide both sides by 18 to get my term, to get my x all by itself. So we divide and we end up with x equals -2 for our final answer there. Okay, so for our next set of problems, we have to simplify using only positive exponents. And what this really means is we have to condense to a single base where we have the same base, like here we have m and m, where we have the same base. We want to use our properties of exponents to simplify into a single base. Let's get started here with the problem. Whenever we have an exponent on the outside of parentheses, that tells us to multiply in exponents. And so this is a 3 to the first. I'm going to multiply the 2 times the 1, so that gives me a 3 to the second. And multiplying in the 2 and the 2, that gives me an m to the 4th power. And this is over m to the -3. So at this point here, I have a 3 to the second, which is 9, and I have an m to the 4th still. And what I'm going to do is I'm going to pull the m to the -3 to the numerator. And when we cross the line, we change the sign of the exponent. That gives us 9 times m to the 4th times n to the 3rd. Well, how many m's do we have? We have a total of 7 of them. And when we have the same base multiplied, we add the exponents together. So that gives us a 9m 7th power. Look at our next problem here. Okay, so first things first, I see that I have 3b to the 3rd times a to the 2nd, and then over here in parentheses we have some a's and b's, but we have raised to the -3rd power. The first thing I'm going to do is I'm going to multiply in the exponent. So that's going to give us a 3 to the -3, a b to the -6, and then an a to the +12 power. Let's go ahead from here and put all of our our same bases next to each other. I'm going to put the 3 next to the 3, the a next to the other a, b's next to the b's. Now when we have the same base multiplied, we add the exponents together. So I have a 1 and a plus a -3, that gives me a -2. I have a to the 2nd times an a to the 12th, that's a to the 2 plus 12 there. I have a b to the 3rd times a b to the -6, that gives us a b to the 3 plus -6. This results in a 3 to the -2 times a to the 14 times b to the -3 power. I need to cross the line and change the sign of the exponents that are negative. So I'm going to pull the 3 to the -2 down, and it becomes 3 to the +2. I'm going to pull the b to the -3 down, and it becomes b to the +3 power. Let's look at our last problem with exponents. So first thing I'm going to do here is I'm going to deal with the parenthesis here. And I'm going to multiply in the 2. So that's going to give me a 3 to the 2nd, an x to the 4, a y to the 6th, a z to the 8th over I'm going to go ahead and put the same bases next to each other. So I have a x to the second next to an x to the negative 1, a y to the third next to a y to the negative 2, and then a z to the fourth next to a z to the negative 3. So from here, let's go ahead and simplify what we have in the denominator at this point. We have a x to the second times x to the negative 1. Remember that when we multiply exponents, when we multiply the same base, we add the exponents. 2 plus minus 1 is 1. And then 3 plus minus 2 is a 1. And then 4 plus minus 3 is a 1. Up top, we have our 9x to the 4th, y to the 6th, z to the 8th. At this point, it's a pretty easy problem because if we have 4x's over 1x, we can cross off one of them, leaving us with 3 up top. 6y's over 1, cross off 1, left with 5 up top. 8z's over 1z, we're left with 7 up top. The rule says that we can subtract the exponent. Now, do you have to write this rule like I'm writing now? No, but I'm writing it to reinforce the rule does exist. You can use it. Okay, let's move on to our next set. All right, so for our next problem, we have to solve the equation for x. We have to figure out what x is equal to. And this is a problem that involves a rule called the one-to-one rule. What the one-to-one rule says is that if you have a base that matches a base on the other side of an equation, then the exponents of those bases have to be equal to each other in order for that equation to be true. So a simplified version of this question would be like 7 to the x equals 7 to the second. Well, what does x have to be? In order for this to be true, well, x would have to be equal to a 2. X has to be equal to a 2 in order for that to be a true equation. So over here, we have an equation that's a little bit more complex, but nonetheless, we have the one-to-one rule. We have a base 7 on the left and on the right, and we can say that the exponents are equal to each other. They have to be equal to each other in order for that equation to be equal to each other. So that gives me the ability to solve for x. I'm going to subtract 9x to both sides to isolate the x term on one side and the constant on the other. And that gives me 6 equals negative 6x. And then we divide by negative 6 on both sides, giving us x equals negative 1. Let's look at our next problem. We have almost the one-to-one rule. We don't have it because on the left here we have two bases, not just one. So what I want to do is I want to make this problem similar to the last one, where we just have one base on one side, one base on the other that match each other so that we can use the one-to-one rule. So what I'm noticing right now is I have the same base multiplied. Same base multiplied means that you add exponents. So I'm going to add these two exponents, and that gives me 8 to the 4m plus a minus 2m. And then from here, that gives me 8 to the 2m equals 8 to the m. And now I have my one-to-one rule, which says that these two exponents have to be equal to each other in order for this equation to be true. And so 2m equals m. And I solve for m by subtracting m to both sides. And I end up with a 1m equals 0. Well, that's the same thing as just saying m equals 0. And m does equal 0. If you were to plug it in, you would see that that equation would ring true.